Hello everyone. In this video, we're going to learn how to solve this challenging system of equations from the Vietnam University entrance examination. Alright, so first we need to rewrite this one. Okay, so we need to group this guy and this guy. The second one, we need to distribute this one. Okay, so what do we have? We have x squared plus y. This one I bring it to the left, plus sy plus this one I'm going to factor sy out. So it's going to be sy times s squared plus y equals negative 5 over 4. The second one, I rewrite this one. Distribute this one, it turns out to be plus 2s squared y plus sy equals negative 5 over 4. Alright, next one, observe that the first three terms right here, this is a complete square. Alright, so a complete square is going to be a squared plus 2ab plus b squared equals a plus b altogether squared. So this guy turns out to be x squared plus y altogether squared. Alright, so now we're going to use the change of variable method. So we let x squared plus y x squared plus y equals a, and sy equal b. Now we need to substitute this guy back to this system of equations. So what do we have? We have a plus b times a. So this one I just write a times b. A b equals negative 5 over 4. And the second one I have a squared plus b equals negative 5 over 4. We see that this guy equals negative 5 over 4 and this guy equals negative 5 over 4. So we just equate this guy and this guy. So it turns out to be a plus b plus ab equals a squared plus b. Alright, so we can cancel out b both sides. Alright, so we just bring a squared to the left, so it turns out to be a plus ab minus a squared equals 0. We factor a out, so it could be a times 1 plus b minus a equals 0. So this is 0 product. We let each of this one equals 0. So either a equals 0 or this guy equals 0. So it turns out to be 1 plus b minus a equals 0. Now a equals 0, we substitute into this equation right here. So we have a equals 0 and b equals negative 5 over 4. The second one, we have a equals 1 plus b. We substitute over here. So we have 1 plus b altogether square plus b equals negative 5 over 4. So we have two solutions right here. Alright, so we need to deal with this guy first. So the first one, a equals 0, but a equals s squared plus y. So we have s squared plus y equals 0. b equals negative 5 over 4. So b s squared s times y equals negative 5 over 4. Alright, so from the first equation right here, we need to solve for y. So y equals negative s squared. And we bring this one into the second equation. So the second equation becomes negative s cubed equals negative 5 over 4. Alright, so we multiply both sides by negative 1, so it turns out to be positive, right? Alright, we take cube root both sides, so it turns out to be s equals cube root of 5 over 4. So s equals cube root of 5 over 4, we substitute back over here. So y should be equal to negative cube root of 25 over 16. Alright, so we have the first solution right here. Now we're gonna deal with the second one, which is this guy right here. Alright, for the second system, I need to solve the bottom one first. So I have 1 plus 2b plus b squared plus b equals negative 5 over 4. Alright, so this one I'm going to multiply both sides by 4. So it turns out to be 4 plus, this is 2b plus b, it could be 3b, 3b times 4, it could be 12b plus 4b squared. Alright, and minus equals negative 5, so I add 5 both sides, so it could be plus 5 equal to 0. Alright, so this one I just rearrange, so it could be 4b squared plus 12b plus 9 equal to 0. Alright, so this is quadratic equation, so I just solve this one. Alright, this guy turns out to be 2b plus 3 all together square, the complete square formula is right here, so equal to 0. So it turns out to be 2b plus 3 equal to 0. b equals negative 3 over 2. So b equals negative 3 over 2. I substitute back over this equation right here. So I have a equal to 1 minus 3 over 2. So it turns out to be negative 1/2. Alright. Now from this one, I just solve s and y. So b, which is sy, right? So I have sy equals negative 3 over 2. And a, which is s squared plus y equals negative 1/2. Alright, so this guy right here, I solve for y. The second equation, I solve for y. So y equals negative s squared minus 1/2. I substitute into the first equation right here. So I'm going to end up with negative s cubed minus 1/2 s equals negative 3/2. Alright, so I multiply both sides by negative 2. So it turns out to be two s cubed plus s equals 3. Alright, so now I'm going to subtract 3 both sides. So this guy turns out to be minus 3 equals to 0. This is the cubic equation. Alright, so you just use the rational root theorem. So by observation, I have s equals 1 is the solution of this one. So I just factor this one using synthetic division. Alright, so I have 1 right here, this is 2, this is 0, this is 1, and this is negative 3. If you want to learn how to do synthetic division, check out the video in the description. So I'm going to bring 2 down. Alright, so I use V diagram. 1 times 2 plus 0 is going to be 2. 1 times 2 plus 1 is going to be 3. 1 times 3 plus negative 3 is going to be 0. So this guy will be factor as minus 1 times 2s squared plus 2s plus 3 equal to 0. Now observe that this is a 0 product, so each of them must be equal to 0. But this guy always greater than 0 because the discriminant of this one should be less than 0. Data less than 0. So this guy is always positive because it has the same sign as 2. 2 is positive, so the whole thing should be positive. Alright, so we only have s minus 1 equals to 0. So s minus 1 equal to 0. So s equal to 1. Okay, s equal to 1, substitute back over here, we have y equal negative 3 over 2. Alright, so we have 2 solutions, right? The first one right here and the second one right here. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.